Hey guys, Mr. T here in another video. This one is on graphical solutions for simultaneous linear equations. So this is the initial method of solving these equations, is by graphing them. Graphing both of the equations as lines and then finding the coordinates of their intersection. The x and y coordinates of that intersection are the solution. So the point where they intersect is going to have an x coordinate. That's the solution for x of both equations, and it's going to have a y coordinate. That's going to be the solution for the y for both equations. The only values of x and y that satisfy both equations happen at the intersection of the two lines. So let's see how this works live here. Got an example. Solve the following simultaneous linear equations graphically. So we're being forced to do it using the graph. You've got y is equal to 3x take 1, and x plus y is equal to 3. So the first thing to notice is that we've got these equations in two different forms. One you've got it in slope-intercept form, and the other you've got in general form. That doesn't prevent us from drawing lines for either. It's just getting to that point is slightly different between both. So in slope-intercept form, the number in front, the pronumeral, the number in front, so not pronumeral, the coefficient in front of x is the slope of the line. It's positive 3. So that means it goes across by 1 every time and up by 3 every time. And then the remaining number here, negative 1, is the y-intercept of the line. So now we know where it starts. It starts at negative 1. And based on the slope, it goes across by 1 and up by 3 every time. So across by 1, up by 3. Going the opposite way is down 3, across to the left by 1, down 3, across left. So we have enough dots to connect and form the line using slope-intercept form. That's quite wavy, sorry about that. I'm using a very slippery ruler on a very slippery iPad screen. And we'll have to do, I can't seem to get it any better than that. So that is the first line drawn using slope-intercept form. The other line, so we have dealt with y is equal to 3x take 1. We need to deal with x plus y is equal to 3. Now, drawing a line using general form is in some ways easier because the x intercept occurs when y is equal to 0. X-intercept is going to be when y is equal to 0, so that's going to be dot, sorry. X plus make y 0 equal 3. X plus 0 is going to be x, so x is equal to 3. So the x-intercept is going to be when x is equal to 3. And the y-intercept occurs when x is equal to 0. So 0 plus y is equal to 3. So basically all I'm doing here is substituting 0 into the general form formula. And so 0 plus y is equal to y is going to be 3. So the y-intercept is when y is equal to 3. That gives us 2 points that we can connect together to form the line. So here you can see the intercept occurs, the intersection is at 1, 2, because it's gone 1 across in the x-axis and 2 up in the y-axis. So solve the following simultaneous linear equations graphically. X is equal to 1 and y is equal to 2. We can double check that by substituting in. So y is meant to equal 2, so let's put that into the first equation. Y is equal to 3x take 1. Well, 2 is meant to equal 3 times by x is meant to be 1, take 1. 2 is equal to 3 times 1 is 3, take 1. 2 is equal to 2. So it works for the first equation. Now x plus y is equal to 3. Is that true? Well, x is 1 plus y is 2. 1 plus 2 is indeed equal to 3, so we've double checked that. Therefore, the solution is x is equal to 1 and y is equal to 2. So hopefully you can see that the first method of solving simultaneous linear equations is to graph the line of the equation separately. Here you've seen examples of graphing a line from slope-intercept form and from general form, finding the intersection, and the solution is the x value and the y value there. Hopefully that helps you out, and I will see you in the next video.